Check, 1, 2. Good afternoon. I know everybody's probably looking forward to the happy hour, so we'll try to be quick. And we wanted to talk about our experience of moving to the cloud. We recently moved a lot of our data processing from an in-house Hadoop cluster, physical Hadoop cluster in our data center, to Amazon Cloud. So I know it's not Google Cloud, but I believe that there are a lot of things that are relatable that you can take the lessons learned and apply to Google Cloud or any other cloud as well. So around the last year, we knew that our Hadoop cluster was going to be decommissioned sometime in the beginning of this year. So we had to make a decision what to do, whether we had to purchase new hardware and create a new Hadoop cluster and move all the data and the processing and jobs into the new Hadoop cluster. So we tried that, and we weren't really impressed with the results or the amount of work that we had to do to actually move the data and the processing to a new Hadoop cluster. So instead, we went to a big data training on AWS, and we decided to try the AWS offering and moving it to the cloud. What it did was we essentially took the data that we have and we moved it to AWS, and AWS offers several services similar to Google Cloud. You have a storage service, you have a compute service, and you have processing and several custom applications that you could use without actually even worrying about spinning up virtual machines or managing patches or upgrading or doing clusters or anything like that. Amazon offers several services, database services, EMR service, which is Elastic MapReduce. So essentially, they give you, with a command, they create a Hadoop cluster for you. They do all the work behind the scenes to launch all the virtual machines needed and cluster them together with just one command. So we decided to use their service instead of trying to build our own Hadoop cluster. The problem that we had in-house before we even jump into the details, the problem that we had in-house when we had one single Hadoop cluster, a physical Hadoop cluster, was our workloads were varying from time to time, whereas the Hadoop cluster was the same. It had 100 nodes, and from time to time we had to restate a lot of data, so we needed a lot more compute power, but we could not scale as fast with a physical cluster. However, with the cloud, we could scale as fast as we want, and we could spin up a small cluster for a small load or a big cluster for a big load. And we did a hybrid approach where we process all the data in the AWS cloud. However, we do have a big database in-house that we still kept in-house because of some restrictions. So we have this hybrid model where we put the data in AWS, and S3, as I mentioned, is their storage engine where you would actually store the data, and EMR is their Elastic MapReduce service, which provides a Hadoop cluster. We use that EMR service to process all the data, and we did not have to rewrite any of our transformations because we were using Hive to process the data in our in-house Hadoop cluster, and we essentially took the same code and we were able to run it on EMR without any changes at all. So it was a big plus for us. And the design that we took was, rather than having one big Hadoop cluster like we had in-house, we decided to go with separate clusters for separate data sets. And we do not have any physical cluster that runs all the time. We actually have transient EMR clusters. So every time there is data ready to be processed, an EMR cluster would spin up, take the data from S3, do all the processing, put the output back on S3. Similarly, we have several other EMR clusters that would come up as and when the data sets are ready to be processed. And at the end of the day, all of them go away, but our data is still there on S3, which is what it is, which is the most important thing for us. So it's essentially having a data warehouse in the cloud, moving all the data processing to the cloud. And the principle behind this, if you see, is the separation of compute and storage. In case of a physical Hadoop cluster, you have to have that cluster up and running all the time, even though when you don't have any jobs running, because you need that Hadoop cluster to be up and running for somebody to be able to get even one record out of the Hadoop cluster. Whereas here, we didn't have to do that. The data is on S3, and the data is separate from the compute. And we could launch 2-node, 5-node, 100-node, 150-node Hadoop clusters, all separate, doing separate summaries, without having to worry about, oh, is this cluster big enough for me or not? We launch clusters. We size the cluster according to the job or the task needed. The advantage of this design was we didn't have to worry about having a cluster up and running or maintaining it, tuning it, making sure that it runs all the time. We didn't have to worry about any of those things. We were able to tap into Amazon's spot market, where the equivalent is Google's preemptible virtual machines that they have recently made generally available. You are getting EC2 instance or a virtual machine for 1/10 of the price of a normal, the normal price, because they have excess capacity, but the caveat is that they could take it away anytime. So you have to design your code and your processing to be flexible enough where if the cluster dies, you should always be able to restart and reprocess the data without any problem. And that's what, by separating the storage and the compute, we were able to easily achieve that. And so we were able to take advantage of the spot instances and cut down our bill by 1/10, essentially, than what it would have been if we used the full-priced on-demand instances that that Amazon Cloud provides. And we could launch, like I said, as many EC2 or as many EMR clusters as we wanted, and we did. At one point, we were, on a typical day, we have 500 to 600 EMR clusters that run. All of them spin up and spin down based on the time of the day and based on how the data arrives. And at the end of the day, we have these Hadoop clusters that spin up and process a day's worth of data and then shut down. Some of the processes that we have, some of our summaries, we have this unique requirement of restating data based on some rules that have changed. So we have sometimes a requirement to reprocess 6 months worth of data, sometimes a requirement to reprocess 13 months worth of data. In our in-house Hadoop cluster, we had to balance this restatement process along with the current production process so we don't affect the production deadlines and deliveries that we have for other data sets. So we had to run them in serial order so that we don't overwhelm the production cluster. Whereas in the cloud, we didn't have to worry about any of that because we designed the process in such a way that each and every data set is processed in its own cluster. Each and every day's data is processed in its own cluster. We just had to run the code for all the days that we had to restate the data for. And we had, at one point, 600 EMR clusters running in parallel. Yep.
Were you collecting data at different regions, or were you transferring all the data from one region
data resides in one region. So we created a bucket in one region, and that data stays, and that's our golden source of truth. That's where all the data resides all the time. There was a time where we were launching EMR clusters in different regions. So for example, Amazon has these different regions and different availability zones within regions. So there is a charge of transferring data across the regions. So what we did was, when we had to do that restatement, because if we try to launch all the instances in the same availability zone, we would easily run out of the spot capacity in that availability zone. And also we would be actually bidding against ourselves. We would be competing against ourselves. So we artificially limited ourselves to some 3,000 instances in a particular availability zone. And once we reach that capacity, we reach that limit, we actually launch in a different availability zone. So that way, we were able to launch 600 clusters, and each cluster had 100 nodes. So we had about 30,000 instances running at one point in various availability zones. Are in different regions. Yes. Yes, so we were launching or taking advantage of the spot market in West Coast regions, East Coast regions, and the data or the bucket that we created primarily stays in US standard, which I believe is the US East. But we did pay a little bit extra for transferring data between the regions, but we were ready to take it because that simplifies our process and the data is available quickly. So, yeah, thank you. So that's where we said, squeeze the spot market as much as you can, and we try to take advantage of that, and we size the cluster just big enough to be able to finish the job in 59 minutes. You know, we don't want to be throwing like more and more instances at it to finish it quickly, because then you're like overpaying them, because whether you run a cluster for 5 minutes or 50 minutes, you're still paying them for the whole hour. So why do it sooner and pay them more if you could actually finish it in 59 minutes with maybe fewer nodes or half the number of nodes, because you're going to pay less and you're still going to get the data at the end of the hour anyway. So if your requirement doesn't really have any stringent SLA of like having the data in 5 minutes, then let it run for the whole hour and give it just enough resources to finish the job within 1 hour. So you're taking full advantage of the resources that you get from the EMR cluster. All right. So I'll hand this over to Gaurav, who has been working with me on this.
Hello. Hey. So I'm Gaurav. I work with Durga in data platforms team. I'll basically walk you through like the key advantages we had because we moved to the cloud. So Durga explained you the architecture and the design that we follow. I'll tell you, like, you must have heard of so many benefits cloud had, but how did we touch those benefits basically? So last year around the same time, as Durga mentioned, we had to start a discussion that we had to shut down the Hadoop cluster. So we are like a small team. So ideally as a developer and as an architect, we did not want to spend too much time in reaching out to business that are you going to expand to like international countries for like web properties, or are you going to provide more data? So that's where the cloud played a key role, because we invested our time in like writing code and serving business instead of worrying about the infrastructure. So with the AWS, the main advantage we had was we did not worry about the compute, storage, or anything like that. We just thought, okay, next year we'll have Hadoop cluster running on AWS, and whatever data or whatever requirements we'll have, the infrastructure won't be a burden. So that was the one key benefit we had. Now, the next discussion point was, shall we keep a Hadoop cluster up and running all the time? We have a hybrid model, so most of our users hit the Vertica database. So we thought, okay, we really don't need a Hadoop cluster up and running. because users hit the database always for the reporting. So let's try a model where you create the clusters, you bring them down, and you don't need basically up and running all the time. So the next thing was, like, can you compromise if the cluster is shut down? So that's where the spot instance came into the role that, okay, even if my cluster is being taken away by Amazon, I don't care, because next hour or next day, I can create as many clusters in parallel and recover the process. So that's where I think the cloud, in general, it's not only Amazon, even Google Cloud might be really beneficial, that you pay only for what you use. So if you're using machines, you are paying by hour. If you're using storage, you'll pay per GB. And if you try to use spot market, it's 80 to 90% discounted. So your bill can be really low. So elasticity. So I think one of the problems you have if you try to put a lot of processes on the in-house infrastructure is that you cannot scale. So imagine a case where you have to process like 1 month of data, but your infrastructure is designed to process only 1 day. So you will bring down the existing production processes to be really slow, and you'll also have cases where like your cluster is not being used at all. So that means during that time, you are basically wasting the compute. So the cloud plays really a key role where you scale up and down as per your need. So if you need to process 1 month of data, you put more compute. If you don't need anything, basically you don't have infrastructure at all. So I think that's the key thing which cloud lets you help in scaling elastically. One more advantage you have is like, since AWS provides you infrastructure across the globe, so you don't need to worry about, like, if you have property running in Japan, how shall I transfer the data? The data is by default available across the globe, since there are multiple regions, and within one region, there are multiple AZs. So that's where cloud really plays a key role. Quick and easy deployment. So I think I have been in IT industry for like 5 years, and there have been cases where like I could not do something because I have to ask, like, get permission from either admins or infrastructure team whether we can install this thing on production. And I really hate that, because if I want to like try new technology or new feature, I would like that feature to go into production because it's really going to provide value to the business. So that's where cloud can be beneficial to you, where if you try to separate out the responsibilities of the projects, one single project cannot impact other. So if I'm trying to use a particular feature or technology which other don't need, you can really put that feature or that technology without impacting any other projects. So since we have Hadoop clusters running in parallel, there can be a cluster which is running a pig version, and other clusters can have Hive without even having to test other clusters. So that's where independent responsibilities can play a key role, and obviously you'll help the business quickly. Durable. We all know, like, I think Amazon has some crazy figure that if you put a file on S3, it will be there for like 10 million years or so. So it's highly durable, highly fault tolerant, and we don't even need to worry about the losing data. So that's really good. There are a few data and insight I would like to share. So currently our storage is 150 terabyte compressed data. That's completely on S3. As Durga mentioned, we have a bucket in US East. We don't have cross-region replication, but US East has 5 AZs, so 150 terabytes of data is replicated 5 times for free. On an average day, we are processing around 2 to 3 terabytes of data. So all the Hadoop clusters are not of the same size. Like, for example, hourly clusters are 1 or 2 core nodes, and daily can be 100 and 150. But on an average, on a rough day, we have like 350 Hadoop clusters. The retention that we have defined on the data we have on S3 is 13 to 24 months. And you can set the lifecycle policies either to archive them or like wipe it out completely. So what we do is like we get raw data from the source. Once we have processed the raw data, we keep raw data only for 15 days, like real raw data. We wipe it out completely. But there are certain summaries or certain kind of data set which we put to Glacier. But one thing you need to keep in mind is that Glacier, the retrieval time of Glacier is not like live. It can take up to hours sometimes. So that's where you need to really decide whether you want to put that data into Glacier. We have some data, I think, that we are legally bound to keep it for 7 years. So that kind of data set might be a really good option for the Glacier archival. Okay, so I would like to walk you through a use case which will give you an idea like how a processing in-house versus cloud can really benefit you. So we work in a team where we process weblogs, and sometimes due to business changes, we have to like reprocess everything going back 24 months. So all these things when we used to run in-house, as we know that there are other production processes running, so it really could not process all 24 months like really fast. At one particular day, it could only process few rolling days back, right? So it used to take us a long time, and business will have to wait those many days or months to get that data back. And the funny thing is that during that time, a requirement might change again. So basically, the last requirement was not even met, and there is a new requirement now. But what we did in AWS was we said, okay, since our design is to have one independent cluster, let's have one cluster for all 24 months. So like, if you have to process 6 months of data, that is 6 cross 30, 180 clusters for each particular day. We had to restate data for 3 countries. So 180 times 3 is roughly around 550. So the thing which used to take us few days or months, we could finish that within hours. So those are not the exact numbers, but in-house cluster was 60 times slower than what we did in AWS. So it gave us like 60 times speed of what we could do in-house. To give you a few like number of EC2s, we had 24,000 EC2s running across 10 AZs. So this was primarily US regions. There was a comment from AWS team that if you are trying to use international, especially Europe, you should check with your legal team because there are so many laws there. So I would advise you to go with your legal team first. So I have just one more comment. So one thing that you need to note down here is the Hadoop clusters, which was doing the processing on AWS, had no other process running. So it was dedicated only for the process which it was assigned to. So all the resources were dedicated for the restatement purpose. So the next thing would be cost. So I actually we showed this thing to our management, and the question was there really a need to do this thing in hours or like days? It could have costed you more. But the answer was no. The in-house thing was 4 times more expensive than what we did in AWS. So we are trying to give you things like really cheap within hours, and even if there was no need, business had to wait. So now business can like make mistake 3 times, and we can still give data within 4 days to them. So they can afford to make mistake and try things where we can be so we are in business of like providing data to the business. So that's where like we can tell them, okay, if you want to try a few things, we are ready to provide you the data. So I think that gives both business and us the advantage where we can help each other.
The other point is whether we restated the data in the cloud, whether we restate the data in 10 hours or 10 days, it would still cost the same money, because underlying you're still using the same amount of compute resources. So it doesn't really make any difference in the cloud whether you launch 100 EC2 instances and run them for 10 hours or 1,000 EC2 instances and run them for 1 hour. The cost is still the same. So that's where the difference is in the cloud.
So I think the biggest advantage they had was they had the data available very soon. And like Christine is sitting behind you who report our data, and she was really happy that instead of waiting long time, basically she could see the trends very soon about the changes. And even if the mapping or whatever changes were done were wrong, now they can revert back or make new changes, because next time also the data can be provided really soon, and there is not that much of a cost. So there are reporting tools, I think daily. So most of the reporting we have is at the daily level. So the processing is all batch. That's where like each hour we get file. There is a cluster for that, and at the end of the day, when all the 24 hours have been processed, there will be another like cluster which will process the whole day. At the end of the week, there will be a weekly cluster. At the end of the month, there will be a monthly cluster. So like that. I think honest answer would be we went for a big data training, and it was like we really tried few things that we had in-house, like a file and few Hive queries. Without even a single change, everything worked like perfectly, and that was the clear choice that time.
Yeah, I mean,
So
AWS was the first one we tried, and we saw that first of all, they're giving you a Hadoop cluster exactly as you had in-house. So the Hive queries that we had in-house were running without any changes in AWS. So we didn't have to make any code changes in terms of the transformations and the business logic for moving to AWS cloud.
And
now, we don't know what exactly the competitors had, Microsoft and Google. I didn't see an exact Hadoop offering from Google Cloud so far, based on what I've seen, not a one-to-one yet. But again, we didn't explore endlessly. We just saw this, we liked what we see, and as a company, that's the cloud that we adopted at this point. And we are open to trying other clouds, trying the new services provided by other clouds in the future. And if something meets the use case, then we might consider it. Yeah, there is a charge to take the data out of AWS. There is no charge to putting the data in AWS.
but network will still be charged, even to put the data, right?
No, there shouldn't be a charge to put the data inside AWS.
I'm saying bandwidth-wise, if we use the bandwidth, the
uh,
actual charge might not be there to put the data to S3, but if we are using the wires, that charge might still be there, right, James?
Yeah, it's
Oh,
network
okay.
out. We don't pay for networking. And again, we compress the data using gzip because it compresses it so well. So we don't really pay that much to extract the data out as well. It's trivial. So it's like 2 cents or 2/10 of a cent or 2/100 of a cent per gigabyte of data extracted out. Because we take only summarized data or highly,
Compressed.
detailed data but still compressed out, we don't pay a lot in terms of network charges.
It's a full cost. It's directly.
Yeah.
Yep.
Yeah. Yeah, I mean, the biggest, as you'll see in the next slide, the biggest charge for us is the processing charge, EMR fee, and the EC2 cost. And if you see the storage cost, which is the S3 cost, which is a small portion of it anyway. So the biggest cost is the EMR fee and the EC2 cost, where EC2 cost is the cost of the virtual machines that you're running per hour, and EMR fee, there is a convenience fee that AWS charges for using an EMR service, because they're giving you an option to create an Hadoop cluster with the command, rather than us having to go in and develop code to spin up all these EC2 instances and stitch them all together into a cluster and installing the Hadoop software. All that's managed by the EMR service, for which you're paying a fee. So
it's like a service charge.
Exactly. You are not spending all that time in developing the code to create a Hadoop cluster on the fly. We are relying on that for that. So
one thing to keep in mind, I think Amazon played it really well here. It's the fixed charge. So EMR convenient fee is always 75% of your on-demand charge. So even if you use EC2 Spot, the EMR fee will always be static, constant. Yeah. So whatever data we process on like EMR and we push it to S3, we have a local database like within data center. That's what we have in the hybrid model. So we pull that data out and we load it to the in-house database. But at the end, like I think 1,000 feet for 5 years down the line, if we want to go like cloud all in, there might be like a Redshift cluster or RDS or some other solution. But we definitely want to move everything to cloud. Right now we are using RDBMS.
Yeah, so we do extract the data and load it into a in-house Hadoop, into an in-house database, and that database has been set up and it works, and all the customers are used to querying from there, the speed and everything. Even now, even though we have an in-house database, our analysts are free to log in to the AWS console or account and create a Hadoop, an EMR cluster for themselves, for their analytics, and which they have done. So if you, we have 2 analysts from our team who are here right now. We have trained, we have shown them videos and we have showed them how to actually spin up an EMR cluster, all with a click. They don't have to write any command line code, a little bit, not a whole lot, but they're able to launch an EMR cluster, read data and do some analytics on some data that's in S3 without having to extract it all and bring it in-house. If they really find it useful and that's needed on an ongoing basis, then we can set up a process to extract it and load it in-house.
Yeah. And to add to that, I think one of the biggest challenge to move all into either Redshift or any other RDS, more than technical challenge, it would be a cultural shift for the whole reporting community in the company, because they are right now used to that Oracle, Netezza, or whatever database. So going to cloud might be a tricky thing for them, because there might be a day where you don't have database running up and on, like all the time. So you have your own database during the working hours and everything goes away. So who knows? So
yeah, SQL-wise, syntax-wise, there may be some syntax that's very specific to the technology that we have in-house. If it's standard SQL and used via JDBC or ODBC, then all the online databases, the cloud databases do support those things. So it all depends on what's used in your own organization. If it's simple JDBC, ODBC, and simple SQL over JDBC and ODBC, then you might as well just go to any database that supports those things. We had to write custom code to extract it out of S3 and load it into our database.
They have their own RDS for Oracle.
Yeah,
Yeah.
so EMR does support loading directly into a database in AWS cloud. So you can have a job that does all the aggregation and loads it into a database that's in AWS. Or if you define your networking correctly, maybe also load it into a database into your data center. So if you define the networking and the virtual private cloud correctly, you can have a step in your EMR cluster that would take the output and load into a database directly.
Basically, that EMR will be on your local network then. It's like if you set up the
we
VPN.
decided to decouple that so that we don't have to worry about connecting to our in-house database. That's why we always use S3 as our storage engine, and all the data is read from S3 and returned to S3. And if you have to load it into a database, we extract it from S3 and load it. That way, you're not, first of all, if it takes, let's say, 45 minutes to load into your database, either because your database is slow or for some other reason, then you're not paying that extra charge for EMR. If you store it back on S3 and you shut down your cluster, there is no charge, other than the charge per gigabyte that you extract out. There is no other charge that you're paying for that.
Okay, so the next slide. So there are like a lot of learnings that I think within a short span we had. There are few which we would definitely like to share. So one thing that you can do, right, you can tag all your machines, like what kind of process you're running. Is it a dev project? Is it a QA? Is it a production? Is it needed for business purpose, your own, who is the user for this? One great advantage you will have is definitely the billing. Like you can identify the cost for each tag, and literally you can group by, or you can summarize the billing till each tag. So whatever slice and dicing you want to do on the billing side, tags will help you, and also it will give you an idea about like how much compute is being used by dev machines, QA machines. So that all the resource infrastructure things you want to try. Spot. So
So essentially, you could get how much did it cost to run that one single EMR cluster, up to how much did it cost for me for last month for running my dev environment, for my production environment. If you define the tags correctly, can give you a good breakdown and good insight into where you are spending the most money, and take a good look at, is that really needed or not. And it actually, it opened our eyes to some of the costs. We thought one data set was the most expensive that we were processing, but it turned out to be that was not the most expensive to process or store. There was something else that we were doing that was the most expensive. So it did help us find those things.
So few other things would be like, for example, I always talk to my operation guys, and infrastructure as a code would be an interesting thing, because I was a developer till last year who was writing SQL or some other programming thing, but I am also worrying about infrastructure now. So literally I'm purchasing Hadoop clusters, databases on Amazon every day. So that has to be done through scripting. So how smartly, it's not like we had a presentation, I think few weeks back, where if you just keep on purchasing everything, you might get the Amazon option might, or Google Cloud, any other cloud might be expensive. It's how you like code and smartly utilize those resources will make your things cheaper and will provide you the efficient solution. If you just keep purchasing like on demand and reserved instances, that might not be the solution to move to the cloud. So what for the security? So what we do for the security is like we don't enable SSH port 22, and all our Hadoop clusters are keyless. So like there is no need for operations or production people to log into the cluster. If something has failed, they will be notified, and then they can check what was the failure reason. But if some production cluster has started, it will fail. No one can log into that cluster during the runtime. So all our clusters are keyless. Scale horizontally. So if you if you need more, like if you need more resources, you should scale instead of processing things serially. I think that's why you'd want to move to the cloud. Lose
Instead of scaling it vertically, as in like trying to run this on a bigger machine or more powerful machine, try to break down the problem so that it can be processed, or it can be solved by having more instances or more machines which are smaller. And if you can do that, then you can, like I said, launch 1,000 instances and finish your processing in 1 hour.
Yeah, because even if you have 100 machine running for 1 hour, or one machine each are running for 100 hours, your cost will still be the same. But I'm sure having small tasks for each machine can gain you a lot. So that's why scaling horizontally might be a better option. If you try to make your projects very independent, like don't bundle them together, it can really help you. Like for example, your staging, loading, all those different processes can run independently, and one of them won't stop other to run. So that's where loosely coupled projects might help you a lot. There are other few things that you can try is like try to put versioning or life cycle on your data set, so that as and when you move forward, older data sets either get archived or gets deleted. Try to enable CloudTrail. So that is like one of the security requirements we have, so that everything is audited by the security team. Try to have multiple profiles for the command line interface as well, so that you can really take the advantage of multiple regions or multiple AZs. You're not always stuck with the single AZ, a single region. Try to scale not within a single region for multiple AZs, but try to reach out to other regions as well. If it suits you, try hybrid model, because I think CTO of Amazon also believes that the cloud is not the binary solution. It depends on your need. So if there are some things which are making sense in your own data center, you should definitely try that. You can set up your alarms, and there are a lot of things. I think we'll share the slides. So there are few things that we want to try, I think, down the road or within next year, is which said, right, we'll try to have a database which can serve not only like the data service, but really the data consumption, where business users or reporting team can have something on the cloud. So we want to move to a design where like things are kicked off as and when the data sets or data sets are ready. Like for example, you don't want to keep sending a heartbeat signal to upstream process where it's asking, am I ready to process? Instead, the upstream process should kick off the downstream that, hey, I finished, you can also kick off. There is a very good option that AWS has launched. It's called Lambda. If you're not tried, or if you're trying to explore new thing on AWS, you should definitely check that out. DevOps, I think that's the buzzword of the industry. We definitely want to go there. And we have analytics team within our group, and running Hive or Pig might not be a good option for them. So because it backend, it runs MapR. So we want to try some MPP technologies like Spark, Impala. Facebook claims that they can process petabytes of data using Presto, so that would be another thing we'll try. So these are like few things that we want to try in coming days. So we really thought it.
Yeah, go ahead. So this is a slide that we thought might help. I know we are talking a lot about AWS and what we did on AWS, and this is a Google developer conference. So we explored all the services that Google provides, and we found this link, courtesy that website, that URL down there, which gives you a good mapping of what are the comparable services between AWS and Google Cloud. So if you try Google Cloud, and if you ever want to explore what's on AWS, at least you know what's the equivalent service. Now we started on AWS first, and we are trying to learn what are the equivalent services on Google Cloud. And like I said, we are open-minded. We are willing to try different things, and if it works for us, then we'll start exploring those things. So
Yeah, I think to answer your question, I forgot to add that when we started last year, it was like first step for us to move to the cloud. But uh, as and when vendor is won't be a concern, whichever service will fit our needs, I think that would be the solution. When we started last year, we thought of AWS, but after 5 years, we might be into some other cloud. We don't know. So whichever fits the requirement, that would be the solution. So that's it. Any questions? So our in-house Hadoop cluster was shut down last month. It has been plugged off as well. So we are completely onto AWS now.
so a portion of it, a major portion of it, I mean, there are still some old legacy code that still runs in-house, but a majority of the data processing that we were doing in a physical Hadoop cluster in-house, all of it has moved to AWS now. So that one particular, uh, yeah. Yeah. Yes, absolutely. And because a QA resource can launch a same size cluster as a production cluster with the same version of software that the production cluster is running on, there is no real barrier for doing dev or QA. Earlier, we had the same problem where we upgraded our dev cluster to a certain version, but we found so many problems and we couldn't upgrade the production version and we couldn't downgrade the dev version. So we were like stuck with this dev in an advanced version and production in an older version, and anything that we tested in dev works, and when we wanted to do the same in production, didn't work. So we were stuck in that problem for a long time, and hopefully now we don't have to worry about it at all, because you can get any version, the same version as production, or if we have a new process that we are running, we could try a new version of Hive or Pig without affecting any other process. So that's the other beauty of it, where because everything's run in its own Hadoop cluster, if I am putting in a new process that needs Hive 15 or Hive 20, then I don't have to worry about breaking other processes because everything's running independently in its own Hadoop cluster. So
Yeah, a lot.
yes,
A lot.
yeah,
So one more good thing we have is like sometimes in the traditional world, even if you have to do dev or QA, you really need the production data. So it will take time even to copy that much data from production cluster. Now everything is on S3, so even dev or QA guys have read access, not the write. They can copy whatever amount they need and do like literal data testing before pushing code to production and do the business validation and all those things. So that has really helped a lot. Oh, for that, what we did was we have CloudWatch alarms that dev QA buckets cannot exceed certain size. Like for example, we have 150 terabytes of data on production bucket, but dev or QA can have like 6 or 7 terabytes. If it exceeds that, we get the alarms like emails and alerts, and
So
then we reduce this.
So the roles and policies that we mentioned about, there are enough granular roles and policies that only production users or operations team has write access to production buckets. Only the production processes can write new data or delete any data from the production buckets. Everybody else has read access to production buckets, so they can read the data. Now, we could go and define at a granular level that, okay, this person has access to only this data and subdirectories. That can be done. That will come in the future.
One more thing that you can do is like for production, like for example, we have 13 to 24 month retention. I'm sure dev and QA does not need that much, so you can keep either 3 months. That depending on your dev or QA cycle, and data will automatically wipe out.
You had a question? If so, right now we didn't have any analysts who were hitting our Hadoop cluster, so that's why we were able to do this. Now, as I said, we can have analysts go in and create their own Hadoop cluster, do the analysis they want to do in EMR, and get the results that they want and shut it down as well. So even they can do the same thing that we are doing to process the data in production. There is no need to have one Hadoop cluster up and running all the time and all the users using that same Hadoop cluster. You can go in, launch an EMR cluster with 10, 20, or 100 nodes, as much as needed for your analysis. And then once your analysis is done, save the results out to S3, and you can shut that cluster down. The beauty of it is that you could have all that steps that you have executed once saved, so you could come back and do the same thing the next day and the next day without having to rewrite any code.
We had a
So
watchdog.
we have a cluster watchdog that actually monitors all the clusters and sends out an alert for any failed clusters. And also, there are several things that the cluster watchdog monitors for. Long-running clusters, any cluster that are running over an hour or 2 hours. So if we have a cluster that's running for more than 2 hours, then we get an alert saying, hey, there is some cluster running for longer than 2 hours, take a look at it. We have identified several clusters that were accidentally turned on and forgotten, and we were able to shut it down.
So it's for you, right? And like even the analyst will have the power. Like for example, if you want 1 day's worth of data, you are not stuck with that hardware. You can have like more machines according to your need. So like you can scale according to your need. All the analysts might not have same data demand. That's where you have the infrastructure available. You can scale, like provision whatever you need.
And again, there is an option to use other technologies as well. You don't have to be stuck to Hive or Pig. You could install Impala or any other custom program out there and use and process the data using that without being bound by others. So that's the flexibility that's available here.
And you can also scale when the existing cluster is running. It's not like if you need more compute, you have to shut existing thing down. You can add more power as and when it's already running. So if you think you like in between analysis you need more data, you need more compute, you can add more nodes. Yes, you can do that.
Yeah.
Yep.
And
yep.
if there is one particular step where you would require more nodes, then you could add more nodes for that step alone and then trim it down again. There are several things that are available that can make it efficient. Or you could add all the nodes at the beginning itself to just speed it all up and then finish it in 1 hour.
Depends on to what level you want to do. That's where the flexibility lies. So your question is like someone. Durga is my architect. He
So yeah,
reviews
I
everything.
mean, within our account, anything new that we add, any new data processing that we add, we review the code, review the design, make sure that it's the most optimal. And like I said, we have the golden rule of thumb. If it's running for more than an hour, then we need to look at it.
So one thing I think to answer your question, so since we are also learning, we review everything with Amazon EMR team and like Amazon experts. We have weekly calls with them and we make sure things we are doing might fancy us, but it's according to the standards or whatever they recommend. Yes, we have relationship with them where we get our things reviewed. So right now, since we have the hybrid model, we have some in-house infrastructure as well. So we have like a jump host, which has a scheduler, which kicks off jobs as and when data is available, either to process or pull data down to load to in-house database. So there is a in-house scheduler right now, but there are a lot of options that's what we have to explore, like Lambda. There is a SQS service, queuing service, where you don't need that infrastructure. Things will run automatically as and when they are ready.
So the current way it is job scheduled that would run at a given time and check all the backlog and run the necessary steps for all the backlog available. That's where we're talking about the event-driven design, where rather than it being a batch, wake up and process everything in the queue, it would, as and when the data is ready for a given data set, it would kick off an event and the downstream process would run without having to have a batch job that is scheduled that runs at a certain particular time.
I think we are out of time. So thank you, everyone. Thanks.